Okay, thanks for coming. I'm Jason McGee. This is Lin Sun. She's going to make sure the computer doesn't die while I'm talking. And we're going to talk to you today about a little experiment that we were doing around running Kubernetes with LXC and LXD. And what I want to do is set a little context on kind of why we ran these experiments, and then Lynn's going to kind of take you through the work that we did. So let's start. So as some of you hopefully have seen, one of the things that we recently announced from IBM is support for Kubernetes as part of our public cloud platform, which is called Bluemix. So as of about a week ago, you can go to IBM Cloud and you can create and provision Kubernetes clusters and run container-based workloads on our cloud. We're pretty excited about that, of course, and excited to be here this week and talk with everybody about the state of Kubernetes and some of the work that we've been doing. As part of that service, we've been trying to bring together the power of Kubernetes, which if you kind of look at the 6 items on the left is kind of the key capabilities that we think are really interesting to people around Kubernetes, around service discovery and secrets management and self-healing and intelligent scheduling and kind of all the power that Kubernetes brings to help people build container-based workloads. And we've taken those core capabilities of Kubernetes and we've delivered them as a service on cloud with a capability to automatically deploy and manage your Kubernetes clusters, to design those clusters, to have the resources that you need, whether you're building kind of memory-intensive data and analytics applications or CPU-intensive web workloads. You can design those clusters easily to have the resources that you need to run them. Doing all of that with security and isolation built in and with 100% native Kubernetes experience, meaning all the Kubernetes tools and APIs and extensions and great capabilities that we're talking about this week at KubeCon work within those environments. And we're delivering that through our cloud platform, which is a bigger place that has over 160 additional services that you can take advantage of from Kubernetes. Things like Watson for doing artificial intelligence and machine learning, capabilities around video and IoT and analytics and data, all kind of brought together on our platform. Now, if you look at how we put this together, there's a couple of things that we've done which are interesting. First is the way we deploy Kubernetes in Bluemix is we manage the masters for you. So as a user creating a Kubernetes cluster, you simply tell us how many worker nodes you want. We provision and manage those worker nodes, but we run your masters for you in the cloud. And actually, we use Kubernetes to run Kubernetes. And so we have a large Kubernetes cluster that we run that holds all the masters, all the etcds and all the masters for all of the Kubernetes clusters that we're handing out to you guys to use. And so we can automate the management of Kubernetes. We can scale and provide high availability around those masters. We can allow you to grow and shrink your clusters pretty easily. We run your cluster itself in your account on the cloud, which means that you're running on private networks. You can have isolated resources. You can take advantage of other capabilities in cloud, like if you happen to have things running in VMs or using storage resources, those things all surface themselves very naturally. It was actually interesting to see the Cube 16 discussion this morning about things like dynamic storage provisioning, which were already implemented in our platform. And so when you use persistent resources from Kubernetes, that happens through our cloud, through dynamic storage provisioning already in the service that we have. And as we built this out, one of the things we wanted to be able to do was offer a free tier, offer a place where people could come to IBM Cloud. We recognize that a lot of people are either new to IBM Cloud or just exploring public cloud generally. And it's nice to be able to come to the cloud and create an environment and play with Kubernetes and understand the technology without having to fork out money up front. And so we offer a free tier as part of that service. And that free tier runs in our account. It's very simple for you to create. And essentially what you get with that free tier is a single node Kubernetes cluster. So you get a master, you get one worker node. That worker node gives you 2 CPUs and about 4 gigs of RAM. And you can use that single node cluster to play with Kubernetes APIs and deploy applications. Of course, you can create much larger clusters if you want to, so you can switch over from the free tier to a normal paid cluster, and you can make that cluster as big as you want. And so as the cloud provider, me, the person providing Kubernetes as a service on the cloud, Obviously, there's a cost associated with providing those free tiers. And so we wanted to do some work to look at, well, how can we run that free infrastructure as efficiently as possible? In other words, how can we drive up the resource utilization and the density of that environment so that we can offer it to as many people as possible to give you a good experience experimenting with Kubernetes without having a very large infrastructure footprint sitting behind that. And today, we do that through a single VM. So everyone gets essentially a VM that is their worker node. And what we wanted to explore was, could we run Kubernetes workers for different tenants, for different users of our cloud, inside of system containers on shared hosts so that we could overcommit memory and CPU on those hosts to allow more free tier at higher density. And that's the experiment that Lin and team ran. And so I'm going to turn the time over to her and have her kind of take you through the work that we did. Lin?
Thank you, Jason. Wow, it's hard to hold the speaker. I feel a little bit interesting when I'm going to show a demo shortly with holding the speaker. So one of the key things about the free tier, I really actually love our free tier because it's like simple 1, 2, 3, 4 click. You kind of boom, you have your free tier cluster running. The only thing is kind of take a while. It does take a while to launch a VM, provision a VM. So that's why we're looking at this minimal cost with faster to be able to stand up the cluster, to be able to faster to tier down. Also, because we have a paid tier, we are always taking into consideration of the migration scenario from the free tier to the paid tier. We definitely want to be a very seamless experience in between. So Jason kind of talked about this. So it's really about the density for the free tier. We want to be able to, using memory as an example, for example, with a 4-core, 8-core, 8 gig of memory, we want to be able to run more free tier, get more bang out of the money. We want to reduce the cost. We want really to be able to deployment faster. So you guys can probably tell from our demo today, our free tier does take 5 to 10 minutes to stand up because of the VM provisioning and set up the kube master and the worker and all that. Also, be able to, we also realize a very important characteristic of our free tier is many of our free tier are actually idle. So free tier, our customer really love them because they can click on a couple of buttons, they get their cluster up running, they can run real popular example of guestbook, and then have it running. It's like a fully blown Kubernetes environment with all our capabilities built in. But then customers interested, they can't change, and sometimes they spin up the cluster, they don't really run the cluster with it, or they forgot their cluster. Many of the free tier cluster are actually idle out there. So that's a very important characteristic. So we've done a couple of experiments. The first experiments we actually done was we want to run Kubernetes workers in Docker containers. So Jason talked about our architecture with master being deployed onto Kubernetes while the workers are being running on the VM. So we thought of a natural transition was to be able to run Kubernetes workers in Docker containers using Docker as the way to package Kubernetes workers and be able to run that. And our second experimental was, why don't we just run the whole Kubernetes we're using Linux containers? So by leverage Linux container, provide the isolation we needed for each of the tenants that's been using our free tier. The third experiment we run is run Kubernetes worker, just the worker piece in LXC containers, while the worker, the master still being deployed as the rest of the container service on Bluemix, so that the master would be deployed onto the Kubernetes that runs all the rest of the masters. So let me take you through the first of the experimental we run. So it's funny, we actually got it working. It was a very smooth ride for us. We were able to run package Kubernetes workers as Docker image, be able to run it as Docker containers and be able to talk to the same master that we use in IBM Container Service in Bluemix. But immediately we realized a big issue with Docker containers because they actually require the containers on privileged mode. Some of the Kubernetes worker process, like Flannel, for example, I think the Kube proxy is another example. They require the privileged mode. Given the nature of our free tier, we really want each tenant to be relatively isolated, so we don't really want to give any one of the tenants to have like privileged root access and onto every single other Docker container running on the same VM. So we kind of killed that experiment right away. The second thing we talked about earlier is we started to look at Linux container, and then we find that's right around the time when Linux container also have a container hypervisor released, the LXD, I believe it's probably on version 2.5 or 2.6 right now. So it really provide a new experience for LXC. I don't know if you guys probably familiar with LXC. One thing I noticed with LXC is it's a little bit harder to interact with it as a user. I feel that's also why Docker has gained a lot of momentum by leveraging the Linux container technology, made it really simple. So one interesting aspect of when I start to explore with LXD and LXC is LXD provided a key components, two key components. One is the daemon that helps you to be able to configure the hypervisor. The other thing is the LXC client, which really made it easy as a user for me to interact with the LXC container. So I can create the LXC container. I can do different management capability around it. Very simple. So we're going to talk through that in our demo too. This is not a rewrite of LXC. It's laid by a company called Canonia. So I think they did a really interesting job make it available and easily consumed by the user. You might be wondering, what's the difference between Docker and LXD, right? So I would say Docker really specializes with deploy applications, so you can easily package your application as Docker images and move it to any other where Docker runs in your cloud, in any of the cloud or local environment. The LXD specializes in focus on deploy Linux virtual machine, which really serves our purpose because it provides a lightweight, highly easy to reuse the resources onto the VM. And it serves really well purpose for a free tier. And LXC can be quickly launched, quickly destroyed. So the second experimental we run was running Kubernetes in LXC containers. So what we were thinking is we want to be able to just package the manager and the worker in long privileged LXC containers. So the whole container is just self-contained, and each of our free tier users, they would each get their own containers, and then they would just interact with the Kubernetes through kubectl or the UI of the Kubernetes. So one thing we quickly discovered, though, is when you run long privileged LXC containers, we've had a lot of issue running Docker in privileged mode. As I was mentioning earlier, the Cuban workers, the kube proxy require the privilege mode. The Flannel also require privilege mode. So what we decided to do is, instead of running the traditional way people run Kubernetes, running as containers, Docker containers, we decided we're going to run the kube processes such as the kubelet and the kube proxy directly on the LXC. So that kind of helped us eliminate the problem with running these as Docker containers and on top of the LXC containers. So we were able to work around that problem. We also raised a couple of issues in the community. I have a summary chart that shows some of the issues we find out as we went through this journal. Be able to run the Kubernetes processes directly on LXC. There was some configuration change we had to make in Kubernetes related to out-of-memory score, and the Kubernetes doesn't expose those configurations, so we've been opening pull requests, working with the community on those. So one thing about this experiments, we've been happy with this experiments. However, we talk about the migration scenario for what purpose. We want user to be able to easily migrate from the free tier to the paid tier. Having Kubernetes master and worker running in its own LXC would mean at the end of the free tier, we would destroy the LXC container, which would destroy their master, destroy their worker, and then when the user move them to the paid tier, they would kind of lose their master. So it's kind of a different endpoint for the user to point to. So that's one thing, we were like, well, can we push it a little bit further, which lends to the next experiments we have. So I'm going to talk a little bit in detail onto this one, because this one we really spend most of our time on. That is, we run Kubernetes workers in the LXC container. So on this diagram, you can see we kind of have we kind of have the Kubernetes machine that's dedicated to run the master. It's running on the VM. So it has like multiple master deployed as deployments, running as Kubernetes deployments on top of Kubernetes. So we rely on Kubernetes to help us to manage those Kubernetes masters. And then on the LXD host, which we also run the experimental with a virtual machine, is on this host that we are launching multiple LXC containers. Within each of the LXC containers, so notice we mentioned earlier we're running kubelet and kubeproxy as processes directly on the Linux containers, and we also run Docker, but these two are not running as Docker containers. So we also run Docker, which helps when the Kubernetes request comes in to be able to deploy pods and all that. So basically these kubelet and kubeproxy would be registered back to the master, so that's providing a functional stack of Kubernetes with the workers running on LXC containers. So this helps us with the migration scenario we talked about earlier, because if users are happy with our free tier, they tried, and if they are happy at the end of the day when they decide they are going to migrate, we're just going to shut down their Linux container for this free tier, and then they can provision the paid tier, like Jason mentioned, in their own account. So they'll be running the Kubernetes worker in their own account and point to the same master. So this is just a couple of screenshots. Let me highlight. So this is like on the left side is the master machine where we run a bunch of masters, as you can see. So all the masters are listed and they're exposed as Kubernetes services with no port to be able to provide access for simplicities. It can certainly beyond no port. It could use ingress or no balancer service type, but for the simplicity of the experimental, we just choose no port to experience it. And on the right side, you can see on my LXD host machine where I have a bunch of Linux containers running. Those are as Kubernetes workers. And on this one, so this is trying to show the information of the Linux container. So this is one of the Kubernetes workers. You can see the memory. Sorry, I didn't bring a pointer, so I'm pointing at this now. So you can see the memory. This is right after the Kubernetes worker has started on the Linux container. So it's about a little bit less than 100 meg. So the memory is not intensive at all. And then on this one is right after It's right after we deploy one of our guestbook example. By the way, how many of you have deployed guestbook in Kubernetes? Okay, very good. So after the guestbook example has been deployed, you can see it's about a little bit less than 800 meg from a memory consumption perspective. And then this is the top command on the LXD host, and you can see we still have some free memory and quite a bit in the swap memory available. All right, it's the demo time, so I have to confess I've never shown a demo with holding this thing. I'll see how that works. Huh? Does this work? Hello? Wow. Thank you, guys. That's a big rescue. Is there a way to turn this off so that we don't get echoes? So let me get out of the keynote. Sorry. I've been recently converted to use Keynote, so you can see I've been having trouble. Okay, so now I finally got myself out of the Keynote. So I have a couple of machines. So let me make sure I mention to you some of my machines. So my Linux container host is on 83. So what I'm going to do, can you guys see my screen? Is it better now? Okay. So what I'm going to do is SSH into that machine. And I also have the Kubernetes Master is on 130. So what we are going to do is SSH into that machine also. And while we are waiting, let's do a list command. So by the way, this is the LXC CLI we mentioned earlier. One thing was to note is they have a lot of commands that's making really easy to interact with the Linux container. So we're going to use the list, which can show you how many of workers I already deployed. You can see I have a few deployed. My machine is kind of a little bit, not on memory, but storage-wise, it's a little bit tight. Else I can probably deploy a little bit more. But so far I have 3 running. And let me get on to, this is the Kubernetes machine that runs all the masters. As you can see, we got a bunch of masters running. Like I was mentioning earlier, it's all exposed as node. So what we are going to do next is, notice one of the workers is missing, which I deployed earlier, and I shut it down. So we're going to do a simple script to actually launch the worker. So notice I picked this 130, which is the Kubernetes master, and 32447 is the node port on one of the masters, master 14 here. So, so what it's going to do is going to interact with the LXC to be able to request, go ahead, ask LXD hypervisor to say, go ahead, create me this Linux container called worker 83, and pushing Docker and Kubernetes onto the machine. We had to customize Docker and Kubernetes a little bit because of the out-of-memory score was not configurable. We're still working with community on that. Sorry. Looks like I lose control on this machine. Let me make sure. Let me get onto, let me SSH from. Yeah, it looks the networking is just hanging out for me for a little bit. I've heard earlier the networking at our booth was not great. So hopefully it's back now. So you can see my worker 83 is running. So what I'm going to do is going to exec into the worker 83 and run the bash command. So this essentially gives me the same prompt here, except that this prompt died because I had a networking issue. So you can see I have the start worker command. So this essentially, what the start worker is going to do is going to start the kube proxy and kubelet and go ahead and register with the master. So on here, we should be able to do a get nodes command and see if that node's registered. I might have to pull the recording if the demo doesn't work. I saw a connection issue. Oh, I find an issue here. Actually, I was pointing to the wrong machine, so I actually point to the LXD host. So let me change to this one. Okay, so you can see I was pointing to the LXD machines, and after I switched to point to the Kubernetes master machine that runs the rest of the masters, you can see the worker 83 is registered. So with the worker register, what we are going to do is we're going to do a deployment of guestbook, conferences. And let me go to KubeCon folder. So what we are going to do is we're going to deploy the Redis master on the machine first. I want to make sure I point to the right server. And what we're going to do is deploy the rest of the guestbook. All right, so you can see my guestbook is deployed, and it's probably still standing up, so we can get a status on this. So notice how faster we were able to spin up a Linux container that runs Kubernetes worker, even though we had a little bit of networking issue, but you can see it's like within a minute, boom, your cluster is ready. And then you have a whole cluster to interact with to deploy our guestbook. I didn't see a lot of hands raised for guestbook. So while the guestbook is deployed, let me just quickly show you the YAML file. So essentially, the first one we deploy that has a Redis master, it's a service and deployment, and it's pulling this particular Redis image, and it's asking for 100 meg for memory. And the guestbook YAML file also has the Redis slave in there, which is also deployed as a service. It also has the front end, which is we're going to access the guestbook, and notice it's deployed as a node port. So we're going to access through whatever node port Kubernetes assigned to us. And I guess we have 3 for the front end. So let's go ahead and check our status of the guestbook. Now you can see it's the front end is 3, which is nice. So we talk about we are using node ports. So let's go ahead and get the node port number. So the number is 32557. So let's find out. So one thing we did along with networking is we actually assigned a public IP, sorry, I was on the wrong machine. We actually assigned a public IP onto the Linux container. So let me go back to the host machine and do the IP command, so which would show us the IP address assigned. Which would show us the IP address. So we essentially, you can see here from LXC list command, you can see what is the IP assigned to 83, which is the worker we just deployed, and we just have our guestbook running, and you can see it's mapped to this guy here. So let's go ahead and launch our Safari, and I have to go back to find out the number of the port, no port assigned. So you can see it's a different number every single time. Yay, here's our guestbook running with Kubernetes worker deployed in Linux container. Let's see if it's really working. So you can see this is a guestbook running, fully deployed with Kubernetes, and the masters managed on a Kubernetes machine separate. So it kind of fits our goal for our experimental, where we want to be able to have the free tier to be able to quickly stand up Kubernetes worker, have a working Kubernetes environment for the user to easily interact with, and be able to provide higher density, and be able to fast migrate to the paid tier. So let me continue with our charts here. Okay. Okay, so with this, we actually try to capture a little bit of statistics. So our current free tier, Jason mentioned, but quickly, 2 core and 4 gigabytes memory. So everybody comes to our cloud with the free tier. We kind of give them this much resources, dedicated VM, nobody else can use it. But with our experiment, you can see I actually run the experiment on a pretty small machine. So I run it with 8 core and 8 gigabytes of memory. That's my LXD host. So each of the LXC with Kubernetes worker running, we've measured 100 megabytes is the average, with 140 is the peak. And if we run the guestbook, unfortunately, because we have like multiple replica of the guestbook, it has a couple of services, so it's an interesting application. So it does take a little bit more memory, but at the peak time, which happens about the time when you deploy guestbook, it's about 1.5 gig for memory consumption, but at average, I've seen it down to like 300 and 800 meg. So it's a good example that you can actually show it's running, but not consume a huge load of memory. So Linux container also, LXC supports this hard limit by memory. We haven't had a lot of opportunity to explore, but it sounds really interesting. The hard limit is what I use. It's the default, but the soft limit is interesting. It allows you to set a soft limit, so if nobody else is using the memory, you could potentially, your container could potentially grab the memory and use it. So that's kind of on our to-do list to be able to explore a little bit on that. We can, based on the memory consumption, on my LXD host, we should be able to run 10 Kubernetes LXC workers, assuming 20% of our workers are highly used and the rest of them are idle, which matches a lot of our free tier that's out there today. So this is a list of issues we mentioned earlier. We had issues running with privileged Docker containers in LXD, so it's not fully working, and we upstreamed with this request coming, and we had the out-of-memory score adjustment. Kubernetes hasn't been able to allow us to provide that configuration out of the box, so we end up building a Kubernetes images ourselves for our consumption, and also with RunC. That's why in the experimental you saw that we actually pushed Kubernetes and Docker into the Linux container, because we had a little bit customization building. The summary, I would say the experiment is really interesting. We thought it was amazing that we were able to launch a Kubernetes worker really fast, having a functional stack, be able to working and be able to match into the architecture we landed in Bluemix to be able to have fully managed master and be able to quickly migrate from the free tier to the paid tier. We certainly have a lot of things on our wish list. As always, there's not enough time during the day. So we want to be able to explore the CPU and memory limits we mentioned earlier. They also have a snapshot feature and copy feature that comes with LXD where you can manage your Linux container much faster. So we thought that was interesting. In our demo, we didn't use DNS for service lookup. We actually use the environment for service lookup in the guest book. So we would like to try DNS, having the DNS add-on onto Kubernetes. We also want to play a little bit more with keys and certs, be able to configure that running. So I think that's the end. Any questions? Yes.
Can you explain again why you're not running the master components in the LXC container?
So we did run master components in the LXC container along with the Kubernetes workers, and that experiment went really well too. But one thing we did, we want to be consistent with our offering in Bluemix, where we run master as on top of Kubernetes and provide management capability around the master. So we want to provide a smooth migration scenarios to our user too, so that you can always point to a single master, whether you are in the free tier or the paid tier. Does that make sense?
So there's no technical reason?
Yeah, there's not a technical reason. It's more for our architecture, fits our purpose.
So things like, so Flannel, where does that run on the workers?
Yeah, you would run Flannel on the workers too. So if you run, you could run Kubernetes master and worker all together within one VM or within one LXC. Yeah. Yeah, question?
Yeah, I found it kind of interesting, the way your reasons for choosing LXC. I was wondering, are you at liberty to share what the difference is between this free tier, all-in-one approach that you chose not to use Docker for specific reasons, non-privileged versus privileged? What's the difference between free tier and like the paid architecture? I'm wondering, you have some good examples for this free tier, but I was wondering for the paid.
Yeah, so the question is, what is the architecture difference between the free tier and the paid tier? So as this diagram Jason was explaining earlier, so it's actually very similar. As you can see, we kind of having, like within our data center, we have the carrier, which is the Kubernetes that runs on the masters. So it has like multiple master for each of our tenants. And on the paid tier, is we kind of deploy that 2 gig and 4 gig RAM and 2 CPU into our own account. So we kind of paid for every user of that. And then the paid tier is customer is going to deploy the workers into their own account. So they will be responsible for the cost associated with that too. So it's actually really similar architecture, because they are sharing the same master and the infrastructure that runs the master. I don't know if Jason, you want to add anything?
I mean, the only thing I would add is in the paid structure, obviously you as the user are paying for those resources by the hour. So this kind of desire to drive up density and do overcommit is not something you would want when you're paying for those resources, right? So in the paid clusters, architecture is the same. But you've paid for those CPU and memory resources, so they're dedicated to you. In the free tier, I'm paying for it. And so we ran this experiment where we say, hey, how can I offer more free tier for people at higher density, AKA at lower cost, so that more people can use it. But architecturally, it's the same, right, in how we laid it out. Okay, one more.
I wanted to ask, how many Inventor have you ended up running in
Yeah, we haven't done that kind of scale testing directly on this yet. I mean, it's fundamentally going to be limited by memory, right? And you know what the memory footprint of those individual containers or pods are. So I think that's going to be the limiting factor, especially in the single node case. You're just going to effectively run out of memory first before anything else in the system starts to break. So.
But each kubelet runs Docker behind.
Yep.
We have a lot of issues scaling up Docker. We had a lot of memory resources and CPU resources, but Docker seems to stop 1,000 containers or so, stop working behind. So I wanted to know, how do you manage this thing?
Yeah, in general, in most of the real world scenarios on a single node, we wind up not hitting those kinds of limits directly on the number of containers. It's just not, you know, by the time you take 2 CPU cores and you split it up 1,000 ways, you're not doing very useful work anymore. So it's more theoretical than practical, right? All right, we're out of time. Thank you very much. Appreciate it.